Welcome back, Mr. Hayes, Hayes' World of Math, going through AP Stats from statsmatic.com. As always, if you have any questions, let me know below. So the two big ideas today is, first of all, how does the sampling distribution between two sample proportions work? So this is how it's going to work out. The first thing is the shape. It's going to be approximately normal if both populations hit large counts. So again, remember, large counts, you have to have at least 10 in both the success and failure categories for each sample in this case. Okay, so again, we know how to do this. We're just doing it a little bit more when we've got a two sample proportion. The center makes sense in terms of the true center that we're going to deal with. The center, the mean of the difference of the sampling distributions is going to be the same as the difference of the means of the population. Sorry, lots of words there. I was trying to make sure I got it set up straight. And then last but not least, for the standard deviation, the variability, you end up basically going through and you're going to do both. You can combine the both variances of both populations and then taking the square root of that. Again, this looks intimidating. In practicality, oftentimes people will just calculate these out separately and then put them together. Also helps create less mistakes that way. Big idea number two. For the normal calculations, you've got the difference of means here, because that's where means go, right in the center. And then if this is my sample distribution, what you're going to end up doing, and again, this isn't anything super different. It's basically n minus, or x minus x prime divided by the standard deviation of x. Okay, but in this case here, we're writing in terms of proportions. So this is the difference of my samples. This is the difference of the population proportions. And then this down here is this variability over here. More often than not, the problems that you're going to have, you will have calculated out this separately. So when you type it in here, you don't have to worry about typing it in, the whole thing in again. And again, if you're not, it would be good, in the way that we're going to tell you to go ahead and send this out, is that you will generally go through and calculate out these parts separately, as you will see below. So speaking of below, here is your check your understanding. We're going to look at Westville High School. They're talking about parking passes for juniors and seniors, and we're going to look at those proportions. So take a second, read it, attempt the problem, and we'll see you in a minute. Alrighty, so I'm assuming that you know everything about the parking situation at Westville High School. So the first thing is that we're going to say this, they ask you, is this, what's the shape of this? And we're going to say it's approximately normal, because both the junior and the senior groups, here's my senior group, here's my junior group, are approximately fit into the large counts law. It's not a law. It meets the criteria for large counts. Both are at least, all four groups, the success and failure, all at least 10. For part B, find the mean of the sampling distribution. The mean of the sampling distribution is just the difference between the means of my two populations. So in this case, 65% of the seniors had it, 42% of the juniors had it, so we have a difference of 23%. Calculate and interpret the standard deviation of the sampling distribution. See, I told you we would do this separately, right? And again, go ahead and write all this stuff out. But I would really calculate out this, and then go plus this, and then take the square root of the answer. In fact, I think I still have it up on my calculator. Yeah, in fact, here, you can kind of see what I did here. So I did the first part, and then I added in the second part. Just make sure you use parentheses on the top. And yes, I know by order of operations, it would be fine if you didn't. Do you really want to take that chance? I don't think so. And then at the very end, I did the square root of the answer. Okay, so again, do it in parts just to make sure that you're not you don't miss a division sign, or you miss a parentheses that you're supposed to have, or something like that. So we get it, standard deviation of 0.1253. So in terms of interpreting this, get ready, you know the words typical are coming up, right? So the difference of sample proportions of seniors and juniors who have a parking pass typically varies by about 1.253 from the true difference in proportions. Need to give this a little bit more room for next year. My apologies right now. All right. So again, same interpretation. We're just doing it in context. The only difference is that we're adding the word difference. And then they ask you kind of a practical question. What's the probability that the difference in a sample proportion between seniors and juniors of students with parking passes is greater than 30%? So again, you're going to draw out your nice little normal curve here. We've got 23 as the mean. Here's my 30%. There's my definition there. So then we calculate it out. Now notice here, I'm not going through and doing a whole bunch of the other stuff. We already know that up here, my difference is going to be the difference between, so I've got 30 here. So I already know the difference, we're talking about the difference is going to be 30. The 23 we already calculated up here. So we've already done the stuff in the parentheses. So don't make this any harder than you need to. And likewise, we already have the standard deviation calculated down here. So again, this big, massive, scary formula here, not a big deal. And then down here, we've got this. So we go through and get 0.56 as my z-score. So if you go to table A, you come up with 71.23. And since we're going to the right, we subtract that. And get 0.2877. You get the same sort of thing if you do normal CDF. You're going to start with your low of 0.56 up to your high, and then your your median standard deviation. All right. So that is the difference of proportions in sampling distributions. So again, as I said, depending upon which version of the practice of statistics that you're pulling, your teacher may be moving you up into a different chapter and could be pulling you back. And that's just because of the way that the curriculum has shifted from the time your textbook was made. As always, good to hear from you. Thanks for commenting and stuff. Keep doing that. Subscribe. Send gift card. No, don't send gift cards. You're fine. I'll see you soon. Bye.